Hi, hello, and welcome to the second session of our day 6, the chapter progressions and our 18-day action plan. Let us see some more interesting problems. The most interesting problem is how many 3-digit numbers are divisible by 7? What interesting question. Here we should have the knowledge of 3-digit numbers and how many of them are divisible by 7. Really very much interesting. Let us see how we can do that. And we wonder, and if the same question is asked at some point, we will definitely try to answer. But we never knew that this could be answered under this chapter called progression. Let us see how we can do. So, how many 3-digit numbers are divisible by 7? Let us see the 3-digit numbers. The 3-digit numbers are 100, 101, 102, and so on up to 999. Yes or no? That's good. But the matter is not about all the 3-digit numbers. The matter is about the numbers divisible by 7. So which number is divisible by 7 here? Let us check from the beginning. Is it divisible by 7? 7 ones are 7, 3 remains. So 7 4 is 28, it doesn't go. 101, 7 ones are 7, 3 remains. 31, 7 4 is 28, doesn't go. This also doesn't go. Probably 105 goes. Let us see. 7 ones are 7, 3 remains. 35, 7 5 is 35. So the number divisible by 7 is 105. The first 3-digit number divisible by 7 is 105. Then what can be the next number? Can we guess? If you observe all the tables, you see 7 ones are 7, 7 twos are 14. So what is the difference between the first and second one? It is 7. 14 and 21, the difference is 7. If you take 10th table, 10 ones are 10, 10 twos are 20. The difference between 20 and 10 is 10. That means the difference between those divisible by 7 continuously will be always 7. So if you take 105, the next number will be plus 7, 112. So 112 will be definitely divisible by 7. Let us see if you have a doubt. 7 ones are 7, you have 4 remaining, 42 it becomes, 7 6 are 42. That's it. So you go on adding 7, 119 and so on. But how long? So we have to check the final term. So this is enough for us because this will give you the first term with the common difference and the concept that this is an arithmetic progression. You see, all are differing by the same number 7. That means the common difference is same. So we can simply say this is an arithmetic progression and we can apply the principles of arithmetic progression to find whatever is asked. Let us see what. Now if you go on doing this, let us see whether 999 is divisible by 7. If you have a doubt, please divide it and see. 999. 7 ones are 7, 2 remains. 7 fours are 28, 1 remains. 7 twos are 14, 5 is remaining. So if you take away this 5, this will be divisible. So take away 5 from this, what happens? It will be 994. So 994 will be the highest 3-digit number divisible by 7. Is it really divisible? Let us see. 7 ones are 7, 2 remains. It becomes 29, 7 4 is 28, 1 remains, 14, 7 2 is 14. That's it. Fantastic. So this is the highest 3-digit number divisible by 7. So starting from 105, we go on with the number of numbers divisible by 7 up to 994 because we are limiting to 3-digit numbers only. Now this is the first term, this is the last term, and the common difference is same here. So this forms an arithmetic progression. We should write it. This forms an arithmetic progression wherein A is equal to 105 and D is equal to 7. Last term is equal to 994. Then what do we have to find out? He is asking us to find how many 3-digit numbers are divisible. So for example, if it ended here, we would have said 1, 2, 3. Only 3 numbers are divisible. But we do not know the number. So go on counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So at some point you will get a number to this one. That number is its roll number. So if you find out its roll number, that number gives you the total number of 3-digit numbers divisible by 7. Yes or no? So let us think this to be AN. So AN is equal to 994. Then what do we have to find? Yes, we have to find out the value of N. Yes or no? So you can write it in either of the ways, don't worry. Only that we have to understand this. So at times you have to write it like this as N, at times you have to write like this AN. So let us see what happens. So in arithmetic progression, we know an is equal to a plus n minus 1 into d. Yes or no? So here an is this one. 994 is equal to 105 plus n we do not know, minus 1 into d is 7. What happens? 994 is equal to 105 plus n into 7 is 7n minus 1 into 7 is minus 7. Now what happens? 994 is equal to 7n. This becomes 105 minus 7 becomes 98. Now taking this side, 994 minus 98 is equal to 7n. This becomes 896 is equal to 7n. So n is equal to 896 by 7. This on cancellation gives you 7 1s 7, 7 2s are 14, 7 8s are 156. Therefore, n is equal to 128. You see, we haven't got a fraction or a decimal because we surely decided this belongs to this arithmetic progression. Therefore, it has got a roll number 128. So, in the sequence of the numbers divisible by 7, it stands in the 128th position. That means there are total of 128 three-digit numbers divisible by 7. This is the wonder of maths, wonder of progressions. Hats off to the great scientist of mathematics. Coming to the fifth problem, find the 20th term from the end of AP 3, 8, 13, dash, 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 253. Very much interesting. The AP is 3, 8, 13, dash, dash, dash to be ended by 253. You see, this progression has a number of terms and we don't know how many terms are there actually. And he's asking us to find the 20th term from the end. That means he is not asking us to find the 20th term from the beginning. That would be very easy. A 20 is equal to a plus 20 minus 1 into d. That would have been very easy. But the question is, you have to find the 20th term from that end. So let us see how we can find. So this is a series. So a is equal to 3 here and d is equal to 5 here. And this is an. An is equal to 253. And what is its n we do not know. Why do we need this n, sir? Let us see. We have the formula to find the nth term from this side, but we do not have a formula to find the nth term from this side. Yes or no? Then how do we find it? If we know the total number of terms, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 numbers here. Let us take 7. It is 7th term from here. Yes or no? First, second, third, fourth, fifth, sixth and 7th. So what is its roll number from this side? Let us see. 1, 2, 3, 4. So 7 is the 4th from this direction and 7th from this direction. Now let us take 3. This is 3rd from this direction and let us count from here. 1, 2, 3, 4, 5, 6, 7, 8. So it is 8th from this direction. If you take 5, let us see what happens. 1, 2, 3, 4, 5. It is 5 from this direction. Let us check it from this direction. 1, 2, 3, 4, 5, 6. So its number is 6 from this direction. What do we understand from this? See, add these two. 8 plus 3 is 11. Add these two. 7 plus 4 is 11. Add these two. 5 plus 6 is 11. What is 11? It is one more than the total number of terms. Yes, this gives us an idea. If you want to find out any term from that side, how can we find out? If you find out its roll number from this side and its roll number from that side, it will be one more than the total number of terms. Yes or no? So you should know the total number of terms. So for example, if there are 100 terms, so adding those two will be equal to 101. He is asking us to find out the 20th term from there. So that will be 81st from here because 81 plus 20 is 101. So for this, we should know the total number of terms here. That is nothing but n. So we have to find out n first. Let us see how to find. This is an arithmetic progression and we know an is equal to a plus n minus 1 into d. So n is what? 253 is equal to 3 plus n we do not know. That is what we are finding. Into d is equal to 5. So 253 is equal to 3 plus 5n minus 5. So this becomes 253 is equal to 5n minus 2. This minus 2, if you get it here, this becomes 255 is equal to 5n. Minus 2 becomes plus, therefore 255. Now n is equal to 255 by 5. So if you cancel 5 5s, 5 1s, therefore n is equal to 51. That means there are 51 terms in all in this arithmetic progression. Yes. Now the 20th term from this we have to find out. So let this be the nth term from this. Then what do we know? Roll number from this side and roll number from this side added together must be equal to 1 more than total number of terms. Must be equal to 1 more than total number of terms. So n plus 20 must be equal to 52. So n must be equal to 52 minus 20, that is equal to 32. Therefore, we should find the 32nd term of this progression. That will be the 20th term from the n. So let us find the 32nd term. How do we do that? In this we substitute n is equal to 32. That's it. So an is equal to a plus n minus 1 into d. That is nothing but an is equal to a is what? 3 plus 32 minus 1 into 5. So this becomes 3 plus 31 into 5. So this becomes 31 into 5. So this becomes 155 plus 3, that is equal to 158. Therefore, the 20th term from that end will be 158, which is the 32nd term from this n. Very simple, very interesting and great. Once more, salute to the great mathematicians and the scientists of math. Coming to the 6th problem now, the last problem of this session. The 17th term of an AP exceeds its 10th term by 7. Find out D. What an interesting problem. The 17th term. So, the 17th term will be A17. Exceeds its 10th term. 10th term will be A10. So, this exceeds this one. So, that means this is greater than this one by 7. So, if you subtract this one from this one, you will get 7. Yes or no? This is more than this by 7. So, this minus this gives you 7. Now, what is the D we have to find? So, we know A17 is nothing but A plus 16D. Yes or no? Then A10 is nothing but A plus 9D. Yes or no? Very simple. That is equal to 7. Now, on opening the brackets, it becomes like A plus 16D minus A minus 9D is equal to 7. Plus A minus A get cancelled, and 16D minus 9D is 7D is equal to 7. This gives you D is equal to 1. Very simple. Though the problem appears complicated, it's very simple, you see. This is very important and you should be thorough with. If you are asked to find out 10th term, you should say A plus 9D. That is what gives you the speed actually, and moreover the confidence. That is very, very important. That's it.